Let me go through the objectives. So this is P2.2J. Explain that inertia is a measure of how difficult it is to change the velocity of an object and that the inertial mass is defined as the ratio of force over acceleration. P2.2K. Define momentum and describe examples of momentum in collisions. Um, Apply formulae relating force, mass, velocity, and acceleration to explain how the changes involved are interrelated. Use the relationship between work done, force, and distance moved along the line of action of the force and describe the energy transfer involved. Calculate relevant values of stored energy and energy transfers. Convert between Newton meters and joules. Explain with reference to examples and definition. Explain with reference to examples the definition of power as the rate at which energy is transferred. Recall and apply Newton's third law. Explain why an object moving in a circle with a constant speed has a changing velocity. This is objective P2.3a. Explained that to stretch, bend, or compress an object, more than one force has to be applied. Describe the difference between elastic and plastic deformation, distortions caused by stretching forces. Describe the relationship between force and extension for a spring and other simple systems. Describe the difference between linear and non-linear relationships between force and extension. Calculate a spring constant in linear cases. Calculate the work done in stretching. Describe that all matter has a gravitational field that causes attraction and the field strength is much greater for massive objects. Define weight, describe how it is measured, and describe the relationship between the weight of an object and the gravitational field strength G. Recall the acceleration in free fall. Apply formulae relating force, mass, and relevant physical constants, including gravitational field strength G, to explore how changes in these are interrelated. Describe examples in which forces cause rotation. Describe, sorry, Define and calculate the moments of a force. Explain how levers and gears transmit the rotational effects of forces. Recall that the pressure in fluids, gases, and liquids causes a net force at right angles to any surface. Use the relationship between the force, the pressure, and the area in contact. An object can travel at a constant speed, but how could it be accelerating? So here you've got a diagram of an object that is traveling in circular motion. So although the speed can be the same at all points along the circle, why do you think it would be accelerating? Now, acceleration is a vector. What is a vector? So remember, for scalar, there's only one thing, and the vector has two things. So the scalar has only magnitude. What does a vector have? So a vector has magnitude and direction. In this case, can you see that in the circular path, the direction is always changing. So although the speed stays the same at all points along the circle, the direction is changing. So the direction is changing, the speed is staying constant. And if you look at the last sentence, so if either the magnitude changes or the direction changes, it is accelerating. If you look at this diagram, the action is moving forwards, but the reaction is acting backwards. So in the boat, if someone is walking to the left, then what will happen? If someone is pushing off from the end of the boat, although the person may move forwards, the boat will move backwards. So Newton's third law is, for every action, there is an equal and opposite reaction. Sir Isaac Newton noticed that forces always come in pairs, and that the two forces were always equal in size, but opposite in direction. He called the two forces action and reaction. The force of the rocket on the water downwards is equal to the force of the water on the rocket. So you switch the rocket and the water the other way around, and it is upwards. For this diagram, you have Newton's third law explaining why a rocket engine can thrust So if the fuel is reacting in the engine, in the rocket, and then it expels gases backwards. But because you've got gases expelling backwards, the rocket will move forwards. So the exhaust flow is pushed backwards, the engine will push the rocket forwards. So for every action, there is an equal and opposite reaction. Power is the rate at which energy is transferred or the rate at which work is done. So the equation for power is energy divided by time. Now the units for work done or energy is joules, and the units for time is seconds. So the units of power could be joules per second, and that is the watt. So for example, 1 watt could be 1 joule in 1 second. So if you use one unit of energy in 1 second, that would be 1 watt, and that would be 1 joule per second. For this diagram, you've got a force acting on an object, but at an angle. So in this diagram, you've got force acting northeast, let's just say northeast, at an angle upwards, but the direction of the displacement is horizontal. So supposing you're pushing this box to the right along the floor, but because you're applying the force at an angle and it's moving to the right, you only need the component of the force that is parallel to the direction of the displacement. So you're looking for cos theta, because sine theta is opposite the angle, and that will give you the vertical component. And you want to work out the horizontal component. So F cos theta is the horizontal component. And to work out the work done, it would be F cos theta times D. I'm just going to read through the slide. So here it says calculating the amount of work done by forces. So if I look on the left-hand side, W means work done, F is the force, D is the distance, and theta is the angle between the force and the horizontal. So F is the force in newtons, which causes the displacement of the object. D is a displacement in meters. Theta, the angle between the force and displacement. And W is work in newton meters or joules. So 1 joule is the same as 1 Newton meter, or if you do it in SI units, because newtons, F equals MA, M will be in kilograms, A is measured in meters per second squared, but because you're multiplying by meters, you have M squared. So work done or energy is 1 kilograms multiplied by meter squared divided by S squared. Work is a scalar quantity. Scalar meaning it just has magnitude. You don't need a direction for work. Work is independent of time the force acts on the object. Only the horizontal component of the force F cos theta causes a horizontal displacement. Inertia is the tendency of an object to keep doing what they're doing. If an object is resting, it will continue to stay resting. If an object is moving, it will continue to keep moving. This property is called inertia. The equation for momentum is the mass times the velocity, and the symbol for momentum is p, and p is a vector, momentum is a vector, velocity is a vector, but mass is a scalar. So momentum is a symbol, p is the symbol for momentum, and it is defined as the mass times velocity. Now, this is the equation for the conservation of momentum. So m1u1 plus m2u2 is equal to m1v1 plus that should be m2v2. So m1u1 will be the momentum before the collision of the object m1. m2u2 will be the momentum of the object that has mass m2. Now, if these two objects collide, and then after the collision, let's just say they stay intact but they move separately, then it must equal to the momentum afterwards, total momentum afterwards. So the momentum afterwards of object 1 with mass m1 would be n1 times v1. and the momentum of object that has a mass m2 would be m2v2. So u1 would be the velocity before the collision of object m1. u2 would be the velocity of the object that has a mass of m2 after the collision. Um, Assuming that they stay intact, remember the mass stays the same. That will be m1 times v1 because v is the velocity after the collision, and then you add on to the momentum of object m2. That should be m2, not m1. So the momentum of object m2 would be m2 times v2. What is impulse? Um, Okay, so if we use F equals ma, the equation for force, F equals ma. Now we're going to use the definition for acceleration. The definition of acceleration is the rate of change of velocity. So if we change a into v minus u divided by t, we have F is equal to m. There should be a brackets there. Brackets on the top of the fraction, you should have v minus u. At the bottom of the fraction is time taken, and then close brackets. Now, we don't like fractions. We just want to put, let's just simplify. So if we multiply both sides by t, we get ft is equal to m brackets v minus u close brackets. Let's multiply out the brackets on the right-hand side. So ft is equal to nv minus mu. Now, what is on the right-hand side? So we've done momentum because the equation for momentum is mass times velocity. So you have mv minus mu. This is the change in velocity. Sorry, the change in momentum. Because v is the final velocity, u is the initial velocity. So when you have mv minus mu, that is the change in momentum. Now the change in momentum is on the right hand side. Let's have a look on the left hand side. On the left hand side, you've got force times time. Now that is the definition of impulse. So impulse is change in momentum or force times time. Now you could use the units Newton seconds because the units for force is newtons, the units for time is seconds. So you put them together, newtons for force is newtons, units for time is seconds, it will be Newton seconds. You could the units for momentum would be kilograms times meters per second. So it will be kilograms meters per second. For this question, let's just say that you've got two balls coming together. So two spherical objects are coming together. So you've got one spherical object that has a mass of 1 kilogram traveling at 2 meters per second. It collides with another spherical object with mass 2 kilograms traveling in the opposite direction with 1.5 meters per second. After the collision, the mass of 1 kilogram is traveling at 1.5 meters per second to the left, and the question is asking what is the speed after the collision of the 2 kilogram mass. Alright, so work out the total momentum before. So the momentum of the 1 kilogram mass would be 1 kilogram times 2 meters per second. So that would be 2. And the momentum of the 2 kilogram spherical object would be 2 times minus 1.5 because it's going to the left. If we take positive as going to the right, negative would be to the left. So 2 times minus 1.5 would be minus 3. Let's have a look on the right hand side of the equation. So the total momentum after. So the momentum after the collision of the 1 kilogram mass would be 1 times minus 1.5 because minus is going the opposite direction. And then we are adding 2 times the velocity. Now, although we don't know the direction, the maths will work it out for us. Okay, so on the left hand side, you've got 2 minus 3, and that is equal to minus 1.5 plus 2v2. So 2 minus 3 is minus 1, that's on the left hand side. On the right hand side, you've got minus 1.5 plus 2v2. Now, the minus 1.5 can go to the left hand side becoming plus, or you can add both sides by 1.5. So minus 1 plus 1.5 is equal to 2v2. And then on the left, minus 1 plus 1.5 is 0.5, and that is equal to 2v2. and then divide both sides by 2, you should get v2 as 0.25 meters per second.